Hello, my name is Leanna Paul, and I'm a genetic counseling assistant who supports Genome Connect. In this video, I will outline how patient data sharing can inform our understanding of genetics, health, and rare disease. I will also discuss how individuals, advocates, and patient registries can engage in data sharing through Genome Connect and the Patient Data Sharing Program. As you know, definitions of rare disease vary, but an estimated 300 million individuals worldwide live with a rare disease. That translates to roughly 1 out of every 26 people. While rare disease can be caused by many factors, 72% are believed to be the result of genetic changes, or what we call variants. Advances in technology have allowed for the identification of an increasing number of genetic variants. Although we are now able to identify many more genetic variants, we do not always understand how those changes affect health and disease. Even if we do know that a genetic variant is associated with a rare disease, we still often have much to learn about that condition's symptoms and features. Genome Connect is a patient registry partnering with patients interested in sharing their genetic and health information. Genome Connect is a project developed by the Clinical Genome Resource, also known as ClinGen, which is funded by the National Institutes of Health. ClinGen encourages laboratories, researchers, healthcare providers, and patients to share their data to help increase our understanding of genetic changes, genes, and rare disease. Genome Connect is open to anyone who has had genetic testing, regardless of the result or diagnosis. Participation in Genome Connect includes 3 main steps. First, if someone is interested in participating, they sign up and consent online. Second, they will be asked to complete a survey that will ask questions about their health history and diagnosis. Third, they will upload a copy of their genetic testing report or provide permission for Genome Connect to request the report from their healthcare provider or the laboratory that completed their testing. Based on a participant's health history and genetic results, participants may be recontacted to collect additional information. Once participants provide their genetic and health data, their information is de-identified, which means that personal details like name and date of birth are removed. Genetic variants, along with some high-level health history details, are then securely shared with databases, including ClinVar, making the information publicly accessible to researchers, laboratories, and healthcare providers. There are 3 main benefits of individuals choosing to share their genetic and health data. First, individuals who choose to share their data contribute to our understanding of genes and genetic variants. Individuals who choose to share provide additional health and family history compared to what is typically shared by researchers, laboratories, or healthcare providers. Second, individuals might also share genetic variants that have not been shared previously. By providing additional health details, family history, and additional genetic variants, participants can inform our understanding of genes and genetic variants and their relationship to disease. To illustrate how patient data sharing can provide valuable information that expands our knowledge base, I wanted to share a case example. For the purpose of our discussion today, I will call this Genome Connect participant Ella. Ella is a pediatric patient with a history of seizures beginning in infancy. She had genetic testing in 2015 and a variant in the gene SCN8A was found. SCN8A is a gene associated with a seizure condition. Ella's parents were tested and the variant was not found in either of them, suggesting the change is de novo, or new and unique to Ella. When a genetic testing laboratory identifies a genetic variant through testing, the next step is to categorize it based on the information available. If there is significant evidence that a genetic change causes a disease, they categorize it as pathogenic. Alternately, if there is compelling evidence that the change has no significant impact on health, it is categorized as benign. For many genetic changes, there is simply not enough genetic information to put it in either group, so it is categorized as uncertain. Based on the information available in Ella's case, there was enough information for her laboratory, Lab 1, to classify the variant as pathogenic. This gave Ella and her family an answer for her seizures. Her family then chose to participate in Genome Connect, so her information would be shared. Genome Connect submitted Ella's de-identified genetic information to ClinVar. At the time of our submission, there were two other records in the ClinVar database. Lab 1, the lab that performed Ella's genetic testing, had already submitted the variant as pathogenic, and Lab 2 had submitted the variant as uncertain. The Lab 1 record contained fewer details about Ella's clinical history and her parents' testing compared to the Genome Connect submission. Laboratories have these details but often are unable to share them with ClinVar. After Genome Connect's submission, Lab 2 reached out to our team to ask more about this participant and confirm the variant was de novo. In their patient, they were unable to perform testing of parents, and knowing if a genetic change is new and unique to a child can be incredibly helpful in understanding that variant's impact on health. We were able to confirm the variant was de novo and share that back with Lab 2. This information then allowed Lab 2 to reclassify the variant as pathogenic and update their patient's report. Ella's results and care were not impacted, but their family taking the time to share her results and enroll in Genome Connect ultimately enabled another family to get clear genetic test results. Data sharing can also help Genome Connect participants remain up to date about their genetic testing results. As the last example shows, classifications of variants may change over time as we learn more. Because of this, Genome Connect gives participants the option to receive updates about their genetic testing results if identified through the registry. To date, 47 updates have been identified and shared with participants. This brings me to the story of a second Genome Connect participant who I will call Emily. Emily is an adult with a history of seizures and an intellectual disability. Her mother chose to enroll her in Genome Connect after she had several genetic tests in 2016 that did not provide an explanation for Emily's history. Emily's testing did identify an uncertain genetic variant in the gene called CSNK2B. This genetic change was uncertain because at the time, CSNK2B was a candidate gene. Candidate genes are those that may be associated with a set of symptoms based on preliminary research of the gene's role in the body. However, more research needs to be done to understand what the gene does in the body and whether it is tied to health and disease. In 2019, Genome Connect became aware of new research suggesting a relationship between CSNK2B and intellectual disabilities and seizures. Because of this new information, we were able to contact the family to inform them that there might be an update to Emily's genetic test results. The family then reached out to their provider and received an updated report, noting that this variant was an explanation for Emily's history. By participating in Genome Connect, this family was able to receive updates about Emily's results and ultimately end their diagnostic odyssey. Finally, data sharing can enable individuals to form connections. Genome Connect gives participants the opportunity to receive information about research that is relevant to them. Genome Connect also allows participants to choose if they would like to connect with other individuals in the registry. Those that choose to connect with other participants can match based on gene, disease, or geographical location. ClinGen created Genome Connect to facilitate sharing of individuals' genetic and health information with databases. Genome Connect is just one of many patient registries. Other registries are collecting valuable genetic and health information, but it might not be accessible to researchers, laboratories, and healthcare providers. Genome Connect is working to expand the sharing of genetic and health information by working with external patient registries and advocacy organizations through the Patient Data Sharing Program. By engaging more individuals in data sharing through external registries, we can increase our genetics knowledge base and offer individual patients the other benefits of data sharing. Altogether, Genome Connect in partnerships with 10 external registries have engaged over 4,600 individuals from 52 countries in data sharing and have resulted in the submission of over 1,900 unique variants to publicly available databases. There are several ways to get involved in data sharing, and they might look a little different based on your role. If you are an individual who has had genetic testing, you can engage in data sharing through Genome Connect or through another registry that offers the ability to share data. If you are part of an advocacy organization or represent a registry, You can connect with Genome Connect to discuss how to enable data sharing for your group. And if you are a clinician or a researcher, you can encourage your patients to share additional data as well as use patient data that is already gathered to inform your work. We hope that this video has given you a good introduction to Genome Connect and the Patient Data Sharing Program. For more information on Genome Connect or to register, you can find us on the web at genomeconnect.org. For more information about the Patient Data Sharing Program, you can visit us at clinicalgenome.org/genomeconnect. If you have any specific questions, you can email us at info@genomeconnect.org.